Okay, listen up here, guys. So, first thing we went over in this unit was climate. Okay, and you need to know the following things. You need to know the components of climate: temperature, precipitation, light, and wind. Okay, and you need to know the factors that affect climate: latitude, altitude, mountain barriers, proximity to oceans, centers of high and low pressure. Okay, all of that important stuff. Okay, that we went over. Okay, because there could be some multiple choice questions about that. You know, which of the following is not a factor affecting climate, or which of the following are components of climate, stuff like that. Sure, there could be multiple choice, but here's how that's really going to get tested in the written response. Okay, you will get a question that has a map of Canada. Okay, I will pick a location in Canada and I will put an arrow to it in case your geography is not good. Okay, I will indicate where that location is on the map. Okay, and then you will have to tell me what factors most affect that city's climate and how. So in your explanation, you will identify, let's say, 3 factors that would be most important. Okay, explain them. And then the other 2 marks is in your explanation, do you tell me how, let's say, for example, being right behind the Rocky Mountains, okay, might affect your precipitation, your patterns of prevailing winds, okay, things like that. What effect would your latitude have on your temperature? Okay, maybe your precipitation, maybe your patterns of prevailing winds. Okay, so when you're doing an explanation, you're saying, you know, because Okotoks is right behind the Rocky Mountains, it is in the rain shadow of the Rockies, therefore that would cause lower precipitation. Okay, because of its latitude, it would also experience distinct seasons where the light changes and the temperature changes throughout the year, being lowest in the winter, highest in the summer. Okay, and winds would typically come from the west. Okay, I think already I've only named 2 factors affecting climate, and I've already covered all 4 components. Okay, I've already covered temperature, precipitation, light, and wind. Okay, and I've only done 2 components, or 2 factors affecting climate. Okay, the third one I would pick for Okotoks would probably be altitude. Okay, we are almost 1,100 meters above sea level, and that can also affect our temperature, making it a bit cooler. All right, I would not expect you to know the altitude, okay, of a place, but if I pick something that's right on the ocean, it's at or close to sea level. Yeah. Okay, so then you can use that. So that's what you're going to be asked to do. Okay, so you have to be familiar with all of those things and know how they interact and affect each other. Make sense? Okay. All right, second thing we talked about, okay, climate graphs. So we've already said the climate graph question is in the written response. Okay, and you'll be asked to tell me which of the biomes we went over that climate graph would fit with. Okay, so what I'd be looking for in an answer, okay, for a few marks, probably 2 or 3, would be you telling me what the climate graph says. Okay, if you see, for example, a flat line, okay, for temperature, where does that tell you that that biome is likely located?
On the equator.
Near or at the equator. Yeah, near or at the equator, because if the temperature line is flat, that means that the amount of light, intensity, and duration does not change throughout the year. Okay, there's 1 mark. You've told me I'm interpreting the graph. I know that this pattern on the graph means this. Okay, and then maybe you look at the temperature bar, or the precipitation bar, sorry, and you see that they're all very low. Okay, in some months there isn't even a bar. Okay, and you look at that and you say, okay, well, this graph clearly shows that the precipitation here is incredibly low. Okay, this would indicate a very hot, dry area. Okay, this then likely means that this is an equatorial hot desert. Okay, because equatorial hot deserts will have high temperatures that are regular all year long, low levels of precipitation, and that would lead to, rolling sand dunes and only like cacti and scrubby bushes growing. Done. Okay, you've talked about what the climate graph says, what that means, and why you think it's this particular biome. Okay, the explanation is important, because if you by chance pick the wrong biome, but you still interpret the climate graph correctly, you can still get some marks. Okay, because there's a few biomes where it's like, yeah, that could be, prairie, or that could be taiga, and the only difference really is, where the temperature curve goes. Okay, so as long as you interpret the graph and tell me what the graph is saying, even if you pick the wrong biome, you could still get 3 or 4 out of 5. Okay, depending on your interpretation. Does that sort of make sense? Okay, so do a good job of that part of it. All right, after climate graphs, okay, then we talked about energy transfers in a global system. There are lots of questions in both the multiple choice and the written response where you will have to use the information from this lesson. Okay, so one of the big things from this lesson is the 3 fates of light when it strikes the earth. Who remembers what the 3 fates of light are?
Reflection, absorption, and use.
Use, right, or conversion. All right, so when light hits the earth's surface, some of it will be absorbed, some of it will be reflected, some of it will be used or converted by plants using the process of photosynthesis. Okay, what determines how much of each one of those things happens?
The albedo.
Albedo, okay? And of course the presence of plants that are alive, okay? Which does affect the albedo as well, okay? So if the albedo is really high, then lots of the light will be reflected, okay? Because albedo is the reflectivity. The higher the albedo, the more reflective it is, okay? So then you could talk about that. You'd say, well, the albedo of this area is clearly very high because of this, and that's how it would affect this area. Because the question that's going to ask this, or one of the questions, is going to be, I just went on Google Earth, okay, and I took a picture, okay, I like a little screenshot of an area on Earth, color, okay? You're going to look at that picture and you're going to decide, okay, here's this area, what does it look like, okay? Is it like, did I take a picture of the Columbia ice fields? Okay, if I did take a picture of the Columbia ice fields, spoiler alert, I didn't, okay, but if I did, okay, then you would say, well, this area appears to be covered in ice, which has a very high albedo, and thus most of the light striking this area will be reflected. Any areas where rock is exposed, it could be absorbed and temperature would go up. There are no plants present here, therefore none of the light will be converted by photosynthesis due to the lack of plant life. Done. Okay, you've analyzed the picture, okay? You've told me about the 3 fates of light, and from your knowledge of that, you've applied what you know. Okay, making sense? All right, the other stuff from there would be the methods of heat transfer. Okay, that would be conduction, convection, and radiation. Okay, and you also need to know the roles of the 3 parts of the earth. Okay, within the atmosphere, okay, the atmosphere transfers a lot of the heat, okay, because it's the most fluid. It uses convection, which we feel as wind. Okay, obviously the water cycle and the latent heat within it, okay, is also a big part of that atmospheric transfer, and that's where the atmosphere and the hydrosphere connect, because the liquid water leaves the hydrosphere and enters the atmosphere, okay, during evaporation. Okay, and then for the lithosphere, mostly absorption. Okay, we're not talking about a lot of heat transfer because conduction doesn't transfer stuff over vast distances. Okay, so you could probably work that into 1 or 2 answers. Okay, and there'll be some stuff in the multiple choice certainly about the atmosphere, hydrosphere, lithosphere, latent heat, and things like that. Okay, and then the other thing that was in that lesson were the 3 methods of heat transfer: conduction, convection, and radiation. Okay, there could be a couple of multiple choice questions about those things, but the main thing is there will be a question in the written that will ask you to apply those methods of heat transfer to a real practical situation. Okay, in class we talked about the design of like coolers, insulated mugs, and things like that, and how they prevent the 3 methods of heat transfer. Okay, we talked about how the pink insulation in your walls works and how it prevents heat transfer. Okay, being able to understand and apply that to a real situation could be important. Again, I can see that I did that diagram of the insulation here again, okay, where I had like the cross hatching of the fiberglass fibers. Okay, if I have a whole bunch of fibers like that, Okay, why does that prevent heat from going from the inside of my house through the wall to the outside?
Because it stops convection.
Stops convection. The air is trapped between the glass fibers and it cannot move. Okay, what else does it prevent?
They're really connected to one side to the other, so they can't really like move just like straight through.
Right, there's very few fibers that are directly connected from one side of to the other. Glass is also a poor conductor of heat, okay? And because there's a whole bunch of trapped air, conduction can't occur through gases. It only occurs through solids, okay? So having fiberglass insulation prevents the two main ways that heat could be lost, okay? The last way that heat could be lost is through radiation. So if I paint my walls a light color, am I good?
Yeah.
Okay, that should reflect a lot of the radiant heat back into the house. Okay, the one place where you are going to lose a lot of radiant heat, or at least at night, is your windows. Okay, there's really not much you can do about that. Okay, it's just going to go out there. You could draw curtains, okay, draw your blinds or something like that so that it's kind of blocking it. But other than that, you're going to lose some radiation. If you ever look at like an infrared camera picture of someone's house from the outside, the windows are glowing and the rest of the house is dark. Okay, because heat is coming out through the windows. All right, making sense? Okay, so I would ask you to, if I might give you a structure or a device and ask you to explain how it works in terms of conduction, convection, and radiation, or I might ask you to design one. Okay, and you're gonna say, okay, I want to prevent conduction, this is how I would do it. I want to prevent convection, this is how I would do it. Okay, go from there. Making sense? All right, is level of detail important in a lot of these questions?
Yes.
Okay, is that something we learned from the bio exam?
Yes.
Okay, because this unit is kind of a combination of all three units. Okay, certainly there's going to be some calculation stuff. The specific heat and latent heat questions are going to be calculation based, and you just need to show your work. Okay, but in a question like that, don't skip anything. Okay, you talk about as much as you know. Okay, so that you can get as many marks as possible. If you say, well, I just paint it white. Okay, that's one. Okay, you painted it white. You didn't even tell me why painting it white would work. Okay, tell me why painting it white would work. Okay, well, it prevents radiation because it would have a high albedo and reflect a bunch of stuff. Boom, suddenly that's 3 times as much information as paint it white. Okay, so make sure you have that level of detail. Okay. All right. Wind patterns. There are 2 questions in the written response about wind patterns. Okay, and there's a couple of multiple choice questions as well. Okay, so just as a quick review, okay, wind patterns on Earth. There are 3 bands of wind in each hemisphere. Okay, there are the equatorial easterlies, which we call the trade winds. Okay, there are the mid-latitude westerlies, which we are in the upper part of. Okay, and then there are the polar easterlies, which we have had the pleasure of being influenced by over the last few days. Okay, that's the polar vortex. So know what those patterns are, but know, more importantly, why. Okay, how are they produced? They are a combination of 2 things. They're a combination of convection and the Earth's rotation. Okay, so that's kind of Coriolis effect kind of related. Okay, so make sure you understand how that works. Obviously the equator gets the most energy. The second law of thermodynamics says that energy has to move to less energetic areas. That would be the poles. That's going to cause convection. Earth spins under its convection. We get deflection of winds. That's okay. You got to talk about all that stuff. Okay. All right. Okay, so yeah, know the Coriolis effect, convection, okay? Oh, and jet stream, okay? In terms of wind patterns, that's an important one for transferring energy from equatorial areas to more northerly areas, and there is going to be a question about that, okay? It's asking you to explain how is energy going to be distributed or moved from equatorial areas. Well, you can talk about convection, you can talk about prevailing winds, okay? And you can talk about the jet stream. What kind of energy does the jet stream move?
Heat.
What kind? Starts with L. Latent heat. Okay, remember the jet stream can push those moisture-laden air masses around. Okay, those moisture-laden air masses contain vast amounts of latent heat, and they will bring it to other areas, okay? That's the role of the jet stream in transferring thermal energy on Earth. Okay, you got convection, that's part of it. Second law of thermodynamics, that's part of it. Okay, but the jet stream moving those moisture-laden air masses containing latent heat is another part of it. Okay, then after that we talked about specific heat capacity. Okay, so you'll be asked kind of what that is in the multiple choice. Okay, it's it's a physical property. Okay, it determines how quickly things heat up. Okay, and it's different for every material. Okay, but the big thing is there will be a 5-mark problem-solving problem in the written response. Okay, that is just like the ones on your worksheet. Okay, isn't going to be any trickier or different. In fact, it's easier than a lot of them. Okay, you just have to be able to solve an E equals MC delta T problem. Okay, also know that specific heat capacity is why proximity to the oceans is a factor that affects climate. Okay, the oceans, believe it or not, are full of water. Okay, and water has an incredibly high heat capacity. So if cold air moves in over, say, Victoria, okay, it is not going to make Victoria terribly cold, because if the air is colder than the ocean, energy will flow from the ocean to the air, warming up the air. Okay? The ocean's not going to change temperature very much because it has a very high heat capacity. It can lose a lot of heat and its temperature won't change. The air, by comparison, has a much lower heat capacity. Heats up quickly. All right? So that's why being near the ocean can be a factor affecting climate. Obviously, it can also provide moisture, okay? But in terms of specific heat capacity, that is why. Okay? All right, then we talked about latent heat, okay, the heating curve of water. And we did a few of those problems, okay, using the heating curve of water like this. Okay, there is a question on the unit exam, written response question about latent heat. Okay, you will have to solve it, okay, show your work. Okay, there are a bunch in your digital workbook that we didn't do, okay, that you could use for practice. The answers are in them, so you could check them as you go. And I believe I put one on the review package for this unit exam as well. Okay, so the big thing you need to know in order to solve a latent heat problem is the shape of the heating curve of water, okay, and what formula you use at each step. Okay, anywhere the line goes up, you use
E equals MC.
MC delta T because temperature is changing. Anywhere the line is flat, okay, then you use E equals MLF or E equals MLV. Okay, if it's freezing or melting, it's LF. Okay, if it's vaporizing or condensing, it's LV.
What are specific heat capacities of all of them?
They are on the test or given to you in the question. Yeah, they're either on the front page of the test or in the question, as would be appropriate for whichever one you're doing. Okay, and for the final exam, they are on your back of your periodic table, okay, in the data section. All right, and then the last thing is biomes, which is what we went over yesterday. Okay, so make sure you know your biomes because there are 3 multiple choice questions, okay, where I give you a picture and a description of the biome and you have to pick it, okay, and then there's the climate graph question, okay, where you have to match the climate graph with the specific biome. Okay, is this a short unit? Okay, so there are 25 multiple choice questions. Okay, covering all the stuff we talked about there, so biomes, parts of the earth, soil profiles, like knowing what the horizons are made out of, okay, water cycle, yeah, biomes again, a little stuff on biomes, sunlight, energy transfers, wow, there's a lot of energy transfer stuff in here. Okay, remember I told you lesson 3 was like the most important lesson? Okay, it totally is. Energy transfers. Okay. Yeah, wow. Latent heat, heat capacity, albedo, energy transfers. Out of those 25 questions, like, what, 16 of them, okay, are related to the stuff that is in lesson 3, okay? And some of those questions are also combined with like wind patterns and stuff like that. Okay, now, as I go through this, I see something I forgot to go over, so I will go over it here in just a second. For your written response, okay, there are 9 written response questions, okay, and they are exactly what I told you. The climate graph question, the map of Canada question, okay, the energy transfers from the equator to the poles question, okay, the wind patterns question, the satellite picture question, the energy transfers structure device question, and then a specific heat capacity problem, a latent heat problem, and then the last question is kind of a unique situation, apply what you know and show me how you can evaluate something. Okay, so it's a bit of a different type of question. All right, now, after looking through your exam, there was something I forgot to go over. Okay, and it has to do with energy transfers. Okay? How many people ever noticed that tinfoil has 2 different sides? Okay, there's this side and this side. How are they different? Right, one's polished, the other is brushed, okay, or dull. All right, now, this is really important because A, it's on the test, and B, it's going to save you from a lot of embarrassment later in life. Most people don't understand how tinfoil works, okay? Like, I love barbecue, and when I go to barbecues, I have my own barbecue. If I go to somebody else's barbecue, I always check the baked potatoes. Because most people don't understand that you're supposed to wrap the baked potatoes in tinfoil a certain way.
Shiny side.
Otherwise, no, shiny side in.
That's what I said.
Oh, I thought you said shiny side up. Yeah, okay? Because if you don't, you get to have basically a raw potato. It's gross. Okay? So, you want to wrap the potato dull side out. Because the dull side does what to radiant energy? Absorbs it. Shiny side reflects it. So if you wrap the potato like this, okay, the heat goes into the potato, through the potato, hits the shiny side, reflects back into the potato. Potato cooks really fast. Okay? So when you go to a barbecue, next time you go to a barbecue, go to the barbecue and look and say to the guy, I want that potato. Okay? Because some of them will be wrapped shiny side out. You want to leave that for the people who don't know any better. Okay? You know better now. Okay? This is an important life knowledge moment. Okay? If you use tinfoil, you want to use it properly. Okay? It has a dull side for absorbing and a shiny side for reflecting. If you put the shiny side out, things don't cook fast. They eventually cook. Okay? But that's more about like convection than it is about radiation. Okay? This helps to capture radiant heat. Okay? It's also why there's a big sheet of tinfoil in any car's emergency kit. The emergency blanket in your car's emergency kit, which by the way, if your car does not have an emergency kit, you need to go get one, okay, is just a big sheet of tinfoil. Use it properly. Put the shiny side towards you, okay, because you want it to reflect your radiant heat back at you, okay, if you are wrapped in it. Okay, so it's important that you do that.
My safety kit is a glass breaker, a knife, and a big blanket.
Okay, well, the big blanket part is good.
Yeah.
The glass breaker is good. If you have power windows, it's the only way to get the window open.
Yeah.
Okay? If you're submerged, it's also important because it's very difficult.
But
to
then
get
the big
windows.
blanket isn't useful because it's wet.
Well, but if you were out in the cold, the big blanket is useful. Okay? You should also have a candle.
A candle.
A candle in your emergency kit. If your car stalls and it's cold outside, a candle can actually warm up the inside of your car significantly. They put out a lot of heat, believe it or not. Okay? In a small space like the interior of a car, a candle could help keep you warm. In addition to wrapping yourself in the safety blanket, shiny side in.
Yeah,
Okay?
she did shiny side.
shiny side in, okay? That is super important. All right, so there we go. Life-saving skills at a very appropriate time. Weather has not been very nice lately, okay? And of course, we're entering January, which is the darkest, coldest of all the months. So keep that kind of stuff in mind. Make sure you have a safety kit in your car. If you don't, go get one. You can buy them pretty much anywhere, and they're not super expensive. You can get expensive ones, okay, and they have lots of cool stuff in them. They're probably worth the money, okay? But if you don't have a lot of money to spend, get a cheap one that has at least a candle and an emergency blanket and maybe a glass breaker, okay, in it. Okay, those are important. Okay, the more expensive ones have like first aid kits and like torches, flares, and things like that for the road.
Cool.
Yeah, those can be important too. Reflectors, things like that. Okay, so yeah, make sure you have that. They usually also have a sign that you can put in the window.
Yeah, there's so many
See,
big
that's a good
ideas
Christmas
I could
gift.
complete if I had.
Yeah, it
that.
was very,
I'm sure you were disappointed in it, but it's a good Christmas gift. That's a dad Christmas gift right there. Here's an emergency kit for your
That's
car.
a
I love you.
fantastic
Okay, that is your dad saying, I love you. Okay, you may not have liked it at the time. That's totally what he was saying. I know I'm a dad. That is totally what that means. Okay, I want you to be safe. Yeah,
I like giving my dad tools. Or just
that's
random
like
things.
tools.
Or random
Unless you're
things.
like me, I can't use tools
Oh.
because I suck at everything related to like handiwork. I can't
So
cut
does my
straight.
dad,
nothing.
actually.
Terrible. All right. Any questions on this unit? Anything you want to go over? Okay, so unit exam tomorrow, unless buses don't run, then it's Thursday. Okay? All right. If you haven't watched that biome lesson, make sure you watch it. Okay? I think Cora was telling me she had a good idea. Okay? You can watch that lesson in a lot less time by putting it up to 1.5 speed.
Oh, let's do it.
Okay? I sound apparently better. Okay? And
It
you
goes
put the
faster.
subtitles on. You put the subtitles on. You guys can read quick. Okay? And you'll see all the stuff you need to see. But it doesn't take an hour and 12
I want
minutes.
to do like 3 times that. Yes, like little chipmunk course.
No, I did that at best like
listen,
yesterday.
listen, when I'm at a Swifties, I have like an hour break, and so I have to like.
You have to use it well. Okay? That was a great idea. Okay? I'm not trying to humiliate. I thought it was a great idea. Okay? So there you go. There's a solution for you. Okay? Okay, let's look at chemistry review stuff here. Okay. So final exam review for chemistry. Okay? You guys need to know something first about my final exams. Do not apply this to everybody's final exams because everybody's philosophy on final exams is different. Okay? My philosophy on a final exam is this. What makes a final exam challenging is the amount of material on it, not the level of difficulty of that material. Okay? So when I make up a final exam, I do not put the hardest questions you have seen on every topic on the final. Okay? I put moderate level or easier questions on the final exam because you have to know everything for the final. Okay? So what makes my final exam challenging is that you have to do everything I asked you to do throughout the entire year in a 2-hour sitting. Okay? So I'm not going to give you the hardest mole equation problem I can think of. Okay? I'm not going to, give you the hardest work energy theorem problem or graphing problem that I can think of. Okay? They're going to be middle of the road level of difficulty. Okay? But there's a lot of stuff you have to know. Okay? Not everybody agrees with me. I like to think of them as wrong. Okay? But that's how my exam will work. Come, question.
Is the unit separated, like you do chemistry, the this, or is it all mixed?
It is all separated. Okay, multiple choice and written response are separated by unit. So if you got one unit that you want to do first because you feel best about it, totally do that unit first. Okay, nothing says you have to do the final exam in order. Okay, you have to finish the whole thing, but you don't have to do it in order. Do what you feel best with first. Okay, guys, why is it a good idea to do the stuff you're best at first?
Because it doesn't tire you out.
Okay, it doesn't tire you out. Makes you feel good.
Cry.
Okay? It makes you feel good. It gives you that little boost of confidence. You're like, I know what I'm doing here. I'm doing well. Okay? Then you have more confidence going into the stuff you're maybe not as confident about. Okay? The worst thing is to go, oh crap, I don't know how to do the first question.
Okay,
so
so let's
screwed,
start
and
with
just
right
sit there and
here.
stare at the test. Okay, don't do that. Okay, read over the test. Take 5 minutes. Okay, read over the test, and like I've seen people that, like when I mark the test, they've actually ranked the questions. Okay, that was like question 12, number 1, I'm doing that one first. Question 3, I'm doing second, and they're bouncing all over the place. But it's what they knew how to do. It's what they were confident in. They were jumping all over the place when they did the test, and that's fine.
I feel like that takes so long to like rank it all.
No,
And how long do you have to write?
you have 2 hours.
I'm really slow.
How many questions?
I can't do
50 multiple choice, 15 written. It's about twice the length of a unit exam.
That's not bad. That's not bad.
Sorry, not twice the length, sorry. 1.25 times the length. Okay. So just let me call it up here and I'll get you the actual info here. Okay, so yes, 50 multiple choice questions and 15 written. Okay, now the marks are fairly evenly distributed between the units. Okay, you got 4 units. I think chemistry is about 28%. Okay. Global systems, I think, was closer to like 21%. Physics was like 26, and bio was like 23 or something. I think that adds up to 100 or close to 100. It's around those numbers. Okay, it's pretty evenly distributed, but it's next to impossible to make them perfectly even. Okay, and of course, chemistry and physics, because of the nature of their questions, showing work and stuff, there's more marks there just by the nature of how they work. Okay, in terms of like the amount of questions and time, it's probably pretty close. Okay, on the exam. All right, so for chemistry, first thing you need to know, most basic fundamental skill that you have to have in order to do basically anything in chemistry: naming and writing the formulas for compounds. If you can't do that, you can't balance equations, you can't write equations, you can't do mole equation calculations. You have to be able to name a compound and, more importantly, write its formula. Okay, do you have a ton of worksheets in your chemistry package with keys? Yes. Okay, I posted the keys in Google Classroom. Okay, I think I actually posted them even in the class work section, but if not, they're definitely in the stream. You just have to go back further. Okay, but you can, don't do them all, obviously. Okay, but try a couple at random. Okay, see how you do. If you get them all right, then you probably don't need to do any more. Okay, you're probably good with that. Okay, and that's kind of the delicate balance that people struggle with. Okay, when they're studying for the final, they kind of get caught up doing one thing or another, and oftentimes it's the stuff they're already good at. Okay, it's easy to fall into that trap. Well, I'm doing this, I'm good at it, and you just keep doing it because it feels good to do it because you're good at it. Okay, you need to do the stuff you're not so good at, the stuff that isn't as fun. Okay, so if you're good at doing the formulas, you're getting them all right, stop doing formula practice. Okay, practice writing equations. Okay, or balancing equations, or doing whatever. Okay, so writing chemical formulas, that's going to be important for both multiple choice and written response, because obviously there's going to be reaction stuff in the written response. Okay, so reactions: writing, predicting, balancing. Okay, on your unit exam, I think you had four reactions that you had to predict, balance, and identify the type. Okay, there are 5 types. We went over 5 types, but on your unit exam, there were 4. On your final exam, I believe there are 2. Yes. Okay, so the chemistry part of the final exam looks a lot like the unit exam. Okay, I basically ask you to do the same things, I just don't ask as many. Okay, to start your chemistry unit exam, you had 7 equations to balance. To start your chemistry, your final exam, you have 3. Okay, 3 equations where you're just filling in the blanks on the balance, just like what was on your unit exam. Okay, following that are 2 reactions that you have to identify the type, write out, predict, balance. Okay, so there are 4 marks each. You have 2. And then you have 2 mole equation problems. Okay, on your unit exam, you have 4. Okay, so those are the skills that you have to demonstrate from the chemistry unit. Now, are there some other things in the multiple choice? Yes. Okay, there's some properties of compounds and solubility stuff, okay, in the multiple choice, so you should go over those lessons a bit, okay? But in terms of like marks distribution, those are the big ones, okay? Reactions, writing, balancing, mole equation. Okay, so Avogadro's number, you don't have to memorize it. It's on the back of your periodic table. Okay, mole equations also on your periodic table, so you don't have to memorize it, but you do need to know what each part is for. Okay, lesson 4. Okay, there's going to be some stuff in the multiple choice. That's the properties of compounds. That's the one we did the lab on. Okay, where you had to identify the compounds based on their physical properties. It would be super easy to make up a multiple choice question that goes like this, because I think I had 2 of them on your unit exam. Okay, you have a clear liquid that is soluble in water, does not conduct electricity, and has a strong antiseptic odor. Okay, it is A, sodium chloride, B, water, C, nickel 2 nitrates, or D, alcohol. It's alcohol, okay? I mean, I wouldn't give you one that easy, but, okay, be something like that, right? They list the physical properties and then give you some options, okay? You should probably know the colors of your metals. Cobalt is pink, nickel is green, copper is
Blue.
okay.
I remember.
See, that's good, you remember.
Yeah, dog.
All right, so properties of compounds, know that, okay? Solubility, polar nature of water, there'll be some multiple choice about that.
Oh, I like the
So there could be a multiple choice question, say, that makes you use your solubility chart. Okay, maybe I give you a reaction and I ask you which, if any, of the products are soluble or not soluble. Okay, you have to use your solubility chart to determine which ones would be soluble. Okay, so written response, like I said, balancing, predict balance reactions. Okay, mole calculations. Okay, that stuff we've already covered, but that stuff is all on there. Okay, naming, okay, know your ionic and molecular rules as well as properties. Okay, I would also say that we went over the scientific method a little bit in the chemistry unit. Okay, so if I were to, describe an experiment to you, you would be able to identify the manipulated, responding, and controlled variables in that experiment. Okay, could be a multiple choice question like that as well.
I like the names of the people who made like the atom and the compide and stuff like that.
I'm trying to remember if I put in any names. I don't remember putting in any names. It doesn't mean there aren't any, but if I did put in a name, it would have been somebody like Dalton, or like somebody really important. I'd say Dalton and Rutherford are probably the 2 most important ones in the chemistry unit. Okay, so if we're talking about naming rules, okay, for ionic, which one do you name first, metal or non-metal?
metal.
Okay, and then you name the non-metal and ends in I. Okay. What do you have to, if you're writing the formula, what do you have to do to get the numbers right? Drop and swap, okay? What if you have a Roman numeral?
That's the charge.
It's the charge on the metal. Okay, the Roman numeral tells you the charge on the metal. So if you get a name and it has a Roman numeral, it tells you that, like, if you have iron 3 oxide, it's telling you this is the iron with the 3+ charge. If you get a formula and you have to write the name, then you got to use the drop and swap. Okay, kind of not reverse it, but use the numbers there and the charges to figure out what the charge on the metal would be, and then put in the appropriate Roman numeral. Okay, that kind of stuff definitely going to be in the multiple choice. Okay, but it won't take you long to review that. You guys were pretty good at that. Okay, all right. What's the name of that stuff? Okay, what's the name of that stuff? Okay. What's the name of this stuff?
Iron 2 oxide.
Okay. So, what's the charge on oxygen? Oxygen's always a -2. So how many negative charges are there? 6. Okay, so how many positive charges are there? 6. Okay, what's 6 divided by 2? Whoop, I forgot to put an N there. Iro 3, iron 3, oxide. Okay, keep that in mind. I could put a Roman numeral one in a mole equation question if I wanted to, right? I could say, you know, how many molecules of iron 3 oxide are there? Okay, you better be able to get the formula right from there. Okay. What's that stuff? Sodium carbonate, right, it's got a polyatomic ion in it. So we name the metal, we name the metal first, and the polyatomic ion acting as a nonmetal second. Okay, let's go the other way. What would the formula for that be? I left the charges up here. Okay, so lithium is a +1, nitrogen is a -3, swap and drop. Okay, Li3N. All right, what would the formula for triphosphorus tetrabromide be? Okay. What would the formula for that be? MgO, okay. So Mg is a +2, oxygen is a -2. When I drop and swap, I get Mg2O2, but I would cancel, or I would just recognize right away that charges are already canceling each other and just say MgO. Okay. All right. What does the Roman numeral tell me about copper?
Charge 2.
Charge of 2. What's this stuff? Okay, what's its charge? Okay, is that stuff okay the way it's written?
Yeah.
When would I use brackets?
When you have a charge for, I don't know.
Maybe in this situation?
When you have a charge on a polyatomic
Well, they all have a charge.
ion. Or like when you have a
Right, a number. Yeah, okay. So for this one here, I have nickel 2, so that's the 2+ nickel, with hydroxide, which is a -1. When I drop and swap, I don't just go like this. That means 1 oxygen and 2 hydrogens. I want 2 hydroxides. Okay, that's the purpose of the brackets. Ringing a bell? Okay, so lots of little rules. Okay, we just have to remember them. Okay. What kind of reaction is the first one?
Synthesis.
Okay. Is it balanced? Okay. What do I need to balance first? Chlorine, biggest number, right? Okay. So what do I put here? Okay. What do I put here? 2. All right. What kind of reaction is the next one?
Combustion.
Okay. Do combustion reactions have special rules?
Yeah.
Okay. What are they? balance alphabetically. If there's an even number of carbons, start with a 2, the rule of 2. Okay, so I start with a 2. What's 2 times 2?
4.
Okay. What's 2 times 6?
12.
Okay, what do I need to put here?
6.
Okay, now I have how many oxygens here?
6.
And how many here?
8.
What's 6 plus 8?
14.
14. What's 14 divided by 2?
7.
Okay, could you get one like that?
Yeah.
Yeah. All right, what kind of reaction is this one?
Double replacement.
Double replacement, okay. What should I balance first?
Magnesium.
Okay, so I go with the biggest number. I have sodium and magnesium both as a 3. Why am I choosing magnesium?
Because there's 2 nitrogens beside it.
Okay, it's 2 nitrogens beside it.
That because magnesium is a higher charge.
Magnesium has the bigger charge. The one with the bigger charge is going to have a bigger effect on the numbers in your reaction. Okay, so start with that 3. Okay, there's 3 over here. I put a 3 here. Okay, that gives me 3 oxygens. So what do I need to do over here? Okay, how many sodium does that give me? 6. Okay. That's not good because now, oh no, I've got 3 oxygens. I'm good. Okay, and then what do I need to put here?
2.
Okay, does that make my nitrogens work?
Yeah.
Am I done?
Yeah.
Okay. Okay, see what you remember. How many moles of sodium sulfide are in 250 grams?
Six point something times 10 to the power of 23. 6 point.
But I can't remember what the one was. I don't remember.
I don't know. I've got that.
I remember learning it, I just don't remember. I just don't remember how to do it.
I remember being really good at this.
6.02.
I remember doing bad on this test.
Big empty mold.
6.02 times 10 to the power of 23.
Yes.
Middle one is
That's what I said. When you go down. It's really easy, like, once you figure it out, like, yeah, that's what I remember. I remember once I was using the analogies or something. Such a mold. It's like something you got like on your face or like, I don't want one right here. I got one beside my belly button.
Yeah, on the shelf over there.
Oh no. That's not what I wanted.
A measurement of the number of particles inside
Or inside of something. Sure, exactly.
How many molecules are in cell?
Or Jackson's got it. Jackson's got it. Jackson's got it.
Jackson's always done.
So, N is the number of moles in moles, M is the mass, and the big M is the molar mass.
Molar mass. Oh shoot. That's a big number.
Yeah, you have to like add the things of the
What is the answer? Is sulfur 32.07 or 22? 32.
I feel like I should
What do you plus 32?
Okay,
78.
What's the, I guess like,
Is the molar mass? Yeah.
this is really.
And then because 2 times sodium plus.
And it's just like,
I don't have any
I'm just
bad at like.
Mr. Coder does a really good job at explaining, so I'm just gonna wait.
Yeah, I know.
Yeah, 3.2. Yep.
I remember doing this question.
You're doing better than me.
Uh-oh.
I know.
You got great. I got 0. Oh, did I do it? Because it's little red. So 250 divided by 78. That's the mass. Yeah.
Great.
Do you like to
I got it.
What'd you get? Yes, sir.
Yeah, mid-latitude.
Let's go back in.
I can understand, but it's been a while. It's so bad. The memory is not there.
Oh, this, I remember, it's why the end of it.
All four now.
I remember how easy it was.
I was doing great, and now
Putting all four down.
Oh, yeah, 3.2.
No, I just run out of lead then.
I got it. I remember. Whoever said that. I remember that you had to time mass by whatever the charge was. So this is 22.99 times 2.
Yeah. Oh!
What do you mean?
Okay, well, we'll start recording. I paused for like 5 seconds. But all right. So if I want to solve this one, okay, how many moles? So that means I'm looking for N. Okay, they tell me it's sodium sulfide, so that will help me get the molar mass. Sodium is a +1, sulfur is a -2, so I'm looking at Na2S. So that'll be 22.99 times 2 plus 32.06. 07. 32.07. Okay, I didn't start my calculator. What does that add up to?
78.05.
78.05 grams per mole. Okay, and the last thing they tell me is the mass of it is 250 grams. All right, the good news is I don't have to manipulate the equation. I just have to plug in numbers because it's already set up to solve for N. Okay, so 250 grams divided by 78.05 grams per mole. Oh, and then didn't even start when I pressed it. 3.20. 3.20, okay, moles, okay, would be my units for that, okay? Okay, questions on that one? Because I have 3 significant digits. Yeah. I'm not worried about significant digits on your final exam. I just do that because it's a habit.
So would you accept 3.2?
I would accept 3.2. Yeah.
If there
Or 3.203 or 3.203, whatever else came after it. If you do it right, I'm not worried about the significant digits. You take physics 20, chem 20, bio 20, you got to do sig digs. Okay?
Oh no.
Yeah.
Why being such a meanie?
Okay, see if you can do that one. We did 4 different kinds of mole equation questions, so let's try them all. Okay, so this is the second kind, okay, where you're being asked to calculate the mass. So N equals little m over big M. Okay, we're looking for little m on this one. Okay, we know that the number of moles is 11. Okay, and we are told that it is dinitrogen hexafluoride. Okay, do I reduce that? Why not? It's molecular. I only reduce ionic compounds. Okay, so 14.01 times 2 plus 19 times 6. Okay, so 28.02 plus 19 times 6. Okay, gives us 142.02 grams per mole. All right, we got to solve for M. So M is going to be N times big M. Okay, that'll be 11 times 142.02. All right, so we're looking at 1,562.22 grams. Okay, ringing the bell.
times 10 to the power of 2 because there's only 2.
Oh, yeah, you could, yeah, you could put 1.6, yeah, times 10 to the 2, or 10 to the 3, sorry, yeah.
I don't know.
Okay, remember how to use your solubility chart, okay? So just a quick review here of using the solubility chart, okay? If it says group 1A, looking at your solubility chart, what is it telling you?
Hydrogen, lithium, sodium.
Right, this first group, this is group 1 right here. Okay, so if that ion is with hydrogen, lithium, sodium, potassium, rubidium, cesium, or francium, okay, then you are looking at it being soluble. Okay, so just know that. All right, the second row is not soluble. Okay, so just look for those things. Okay, that's it for chemistry. All right, questions from you guys? Look at that, we're done the chemistry review.
Wait, really?
Yeah.
Yeah!
We might gain back that day if we don't come to school tomorrow. Just in case the buses don't run, we might have gained that Q&A day back, remember? Because I was going to do chemistry after we review the exam on Thursday. We might be okay.
I do that stuff.
And you knew it all. See? Okay, any questions from you guys? Anything you'd like me to go over in more detail or do another example of? Or?
Wait, if we come tomorrow and the buses aren't running, we're just gonna be here, or are you gonna do it?
Every time he gets mad at me.
If
He
you
gets
come
mad
tomorrow,
at
if the buses aren't running, I'm not doing the test.
me. He gets
If you
mad.
got questions, I'll answer them.
You get to study for the test.
Where Avogadro's number? Yeah, okay.
Hey, at least I don't think it's the same goal as you, because Becca has something like grade higher than so get the exact same test. Right, Becca?
What?
Yeah, exactly.
Oh, no.
Like, Becca, what's your hand?
I know what to do.
It's good right here for you. Oh, you guys read this, so you're gonna faster work.
Okay, give that one a try. Okay, looking at this one. All right, so they told us the number of molecules. Okay, that's 8.52 times 10 to the 24. They want to know the mass. If I'm going to get mass, then I need to know the number of moles and the molar mass. Okay, it's copper 2 sulfate, so that's CuSO4. Okay, so that's gonna, I remember copper off the top of my head here. 63.55 plus 32.07 plus 16 times 4. Okay, so we get our molar mass there, 63.55 plus 32.07 plus 16 times 4. Okay, so we're looking at 159.62 grams per mole. All right, I need N. Can I use this number to get it? This number and whose number? Right. Okay, so I'm going to go 8.52 times 10 to the 24, and I'm going to divide that by 6.02 times 10 to the 23. This is the number I have. This is the number in 1 mole. If I divide those two numbers, I get the number of moles. Okay, so in brackets 8.52 E24, 24, okay, divided by 6.02 E23, okay, is going to give me 14.15 moles. I'm going to keep all those decimals, okay, and now I can calculate mass. Mass is N times big M, okay, 14.15 times 159.62. Okay, so times that number there. Okay, and we're looking at 2,259, or with the right number of significant digits, we would be looking at 2.26 times 10 to the 3 grams. Okay, so reminder, okay, buses run, be here, write the test. Buses don't run,
Be here.
don't be here. Okay? No, I'm serious, guys. Okay? I'm serious. If the buses don't run, it's because it's not safe. You as an inexperienced driver are the last person who should be on the road if it's not safe for a professional driver to be on the
That's why I
road.
get my mommy to drop you off.
And that will get postponed as well. Okay? Nothing, and you need to hear this, nothing is more important than your safety. Okay? If it is deemed unsafe to drive buses to school, it is unsafe for you to drive yourself.
It's good there.